Very small exercise about the Euclidean TSP, okay? So that's a question that is very specific for the Euclidean TSP, but not all the TSP are Euclidean. If the current solution has no crossing edges, okay, such as this one, you see that there are no crossing edges. The question that I ask you is, do you think that it could be improved by applying a single two-up move? If you remember from a previous slide, I said that having no crossing edges was a necessary condition for being able to improve. If you would have crossing edges, then you knew that you could improve the TSP. And so is the opposite also true? Does it mean that because you have no crossing edges, does it mean that you cannot improve the TSP total length by applying two-up move? And the answer to that question is no. Okay, so the question is no. And let's see an example here on this small instance. Okay, so that's a small instance, and this is the distance matrix that we have. Okay, you see that it's symmetric, right? You can see the entry 2, 0 is the same as the one of 0, 2, and so on. So this is a symmetric one matrix, and you have 0 everywhere on the diagonal. So let's study here the example. So you see clearly that there are no crossing edges. If I would break these two edges and I would reconnect the circuit like this, okay, I'm reconnecting it like this, you see that I'm introducing now a crossing between two edges, and despite this crossing, the total length has been improved. Okay, you need to remove 355, so that's the purple part. Then you also remove the red part, but you will need to add the brown edge, and you will add also this one, which is 160. And so overall, if I make the summation, my total length used to be 2056, and now it's 2023, so it's a little bit better. And so that's why we have a counterexample of TSP without any crossing edges. And after applying a two-up move, we were still able to improve the total length. And of course, that one is not optimal neither, right? Because you can still break it. So for instance, you could easily decide to break that one, and you could reconnect it like this and like this, and that's even better, right? That's even better if you do that. Okay, I close the parenthesis and I come back to the implementation of the TSP now.